Welcome to the mainframe. When you sit down to feed instructions to a large language model, it feels like you're having a conversation. But underneath the glowing screens, these models don't actually read human language. Before the machine can understand a single sentence you type, that text has to be chopped up into tiny, mechanically digestible pieces. The system doing this chopping for OpenAI is called TikTok. You can think of it like an incredibly fast industrial deli meat slicer built exclusively for data. Let's watch this slicer work on a long word like extraordinary. When this word hits the grid, the machine doesn't see one complete idea. It slices it up into 3 separate smaller blocks. These individual pieces are called tokens. They are the true foundational language of the system. The machine immediately strips away the human alphabet you typed. It only cares about the pure numerical data inside those slices. Grasping this hidden layer of text slicing is your baseline for getting these models to do what you want without burning through your resources. Inside this system, every single slice costs computational energy, and if you're building software, every slice costs real money out of your API budget. The slicer decides exactly where to make its cuts using a method called byte-pair encoding. The rule here is simple. The algorithm is lazy, and it is always looking for shortcuts. Over time, it learns which letter combinations show up the most often. Common everyday words get a free pass. A word like apple glides through the laser grid in one cheap piece. But with complex words, the machine doesn't recognize the structure. It rapidly slices the word into tiny, expensive fragments until it finds pieces it recognizes. If you want to keep your project running efficiently, you must write prompts that minimize the total number of cuts the system has to make. To complicate things further, the slicer doesn't stay the same. Switching from an older AI model to a newer version means using completely different internal dictionaries. Think of it like a currency exchange rate. The exact same sentence will yield completely different piece counts, depending on how that specific model's slicer was trained. And then we have inputs that the text slicer is absolutely not prepared to handle. Let's look at this holographic pizza emoji. You might assume a single graphic is the most efficient thing you could send. It's just one character on your screen. But watch what happens. The text-based algorithm panics. To make sense of the visual data, it breaks the image down into raw computer bytes, aggressively shredding that single emoji into 4 separate microslices. Because the tokenizer spent its life learning human alphabets, any non-standard character you drop into the grid incurs a heavy, invisible penalty. Treating emojis as cute, cheap shortcuts is a fast way to drain a development budget. It proves that the machine measures complexity in a completely different way than we do. You can't be expected to manually guess how many cuts are going to happen across dozens of different AI models. This is where a tool like TokenSense-AI comes in. Think of it as a pre-flight scanner for your prompts, giving you a clear view of your metrics. When you select a specific model, the tool automatically calibrates to the exact slicer settings for that model. It shows you the precise number of slices your text will create before you ever send the request to the mainframe. As you type, you get real-time feedback. You can swap out complex words for simpler ones, testing out different phrasing to find the most cost-efficient structure possible. Operating these systems effectively means stepping past human language. When you learn to see the data exactly the way the machine sees it, you stop guessing and you start taking control.